This is Dr. Daudu. Today we will discuss the creation of discrete distribution. Well, discrete distribution is one of the two distributions we used to have in statistics. The second one being continuous distribution. When it's discrete, we will be summing. The summation symbol is what we'll be dealing with. If it is continuous distribution, it will be integral symbols that we'll be having around. Now, those who saw the last video, the last video I did, will notice that these functions are not stringed anymore. This was the function we found that it is equivalent of this. These two are synonymous. And we find the sum to infinity to be equal to 3. Mind it, these sums are sums from x equals 1 to infinity. X equals 1 to infinity. X equals 1 to infinity. All right. If we have a converging series like this, it is easy to write, it's often easy to write the series to be a discrete distribution. Now, we know that PMF for a discrete distribution is supposed to sum to 1. But in this instance, we have it summing it to 3. There's a way out of that. One way out of it is for us to divide throughout everything here by 3, such that I'll have 1 over 3, 1 over 3, and this will be 3 over 3, which will give me 1. Now, that's one property of a discrete distribution that is satisfied now. One of the properties of the discrete distribution is satisfied. The other property is the fact that the PMF, the probability mass function, this function under summation, the PMF should iterate to values that are between 0 and 1, meaning that the probability mass function, the probability mass function PMF, which is equal to P, often denoted by P subscript X 0 less than or equal to P subscript X less than or equal to 1. It would be ridiculous to have a probability measure that is less than 0. It would be equally ridiculous to have it being greater than 1. If a probability measure is 0, it is an impossibility. It can't occur. And if it is equal to 1, it means it is a surety, it will always occur. Good. So, this, in comparison with that, will mean that our P subscript X is equal to 1 over 3 of 3 over 4 X, which we can write as, 3 raised to power X minus 1 over 4 raised to power X. You can write it as that. Now let's try and iterate that to be sure that this second property is actually satisfied. If we set it from the initial x is equal to 1, putting x is equal to 1 will give us 1 up there, because 1 minus 1 is 0, 3 raised to power 0 is 1, so over 4 raised to power 1, so 1 over 4. That's what results there. Now, at the instance at which x is equal to 2, we are going to have 3 raised to power 2 minus 1, which is 3 raised to power 1, and this will be 4 raised to power 2, 16. So it will be 3 over 16 resulting from there. And at the third instance, in which x is equal to 3, that will be 9 over 64. It should continue like that. Now, you can be rest assured that all the fractions that we form will be less than 1. Why? See something here. 3 over 16 is less than 1 over 4. 9 over 64 is less than 3 over 16, which in turn is less than 1 over 4. It means we have a monotonically decreasing sequence. This is a monotonically decreasing sequence. As such, if the first is not greater than 1, the others will not be, can never be greater than 1, individually, that is. All right. So, and we know that the sum will be 1. We saw that in the last video. Fine. Now that we have this, we sure know these two, the fact that these two properties are satisfied, that and that are satisfied, means that we have a discrete distribution in our hands. Well, what about the properties of this distribution? At least additional properties, parameters, such as the universal mean, then the variance, the arc moment, for instance, moment generating function. How do we get those ones? Getting those ones are easy using the usual technique. I mean, the first one, expectation of x, will be equal to summation x, p of x, p sub x, which is equal to summation x, and our p of x is equal to 3 raised by x minus 1 over 4 raised to the power x. Well, we said x goes from 1 to infinity. That's what it is. Well, to get the variance, we need the expectation of x squared first, which will be equal to summation of x squared piece of x, which is equal to summation of x from 1 to infinity as usual. Okay, x squared 3 raised by x minus 1 over x raised to the power 4. Well, now, armed with these two, we can get our variance of x to be equal to expectation of x squared minus expectation of x squared. Now, if we want the arc moment, that expectation of x raised to power r, it's easy. We merely put summation of x raised to power r here, and we have 3 x raised to power minus 1, 4x. In the x going from 1 to infinity. What about the moment generating function? M sub xt, which is equal to expectation of e raised to power tx, and that will be summation e raised to power tx again times 3 raised to power x minus 1, 4 raised to power x. Okay, so most parameters, most of the time, the parameters are trapped within these 3. That's the expectation for sure. This is the variance. The square root of the variance gives this standard deviation. So if you are able to calculate the variance, then the square root of it will give us the standard deviation. Well, it is possible to have a natural phenomenon or an artificial one that operates in line with this PNF? Well, there are scenarios. You could say a candidate that lacks mathematical acumen attempts the WAEC maths the first time with this probability. He or she repeats it with this probability and repeats it again with that probability. That is one scenario. Another scenario is, there are a lot of scenarios that will fit into this. Well, so as the matters arise, but these ones here, I've given the expression for them with respect to identifying them and stuff like that will take us into series. I want to keep that till next time by God's grace. Thanks for listening. Please like, share, and subscribe.